Hello everyone, Fru here. Welcome to today's lecture. So guys, I am very excited for this particular lecture because we're finally getting into module 5 of our series on Python for beginners. And guys, this is a very fascinating topic that we're going to be looking at today. And for the lecture of today, we're going to be talking about loops. So let me zoom in here for a second so we can see the full content for today. We're going to be talking about for loops, while loops, breaks and continue, else clauses within loops, nested loops, and being able to break a loop. So guys, this is a very fascinating topic. If you're doing programming of any sort, loops is one of those topics that usually come on very frequently, and it's very important that we have good mastery of loops. So that said, before we dive into the sessions to begin, as always, every code that we do is going to be available on GitHub. So if you want to get access to that code, just make sure you go on GitHub, download the my GitHub repository or clone the GitHub repository, and you're going to have access to that. Also, I brought with me a little prop today to really make and bring home the idea of loops. And so what I have on my hand is a band. It's an armband, which I usually have often on my hand. Now, if you look at this, it's kind of like a circle, right? Let me actually flip it inside out. But most people will consider this a loop, all right? And why is it a loop? It's because the start is connected to the end. And you can ask me, but how is the start connected to an end? If you just pick any point and just kind of go around that loop, you come back to the same point. So the start is connected to an end, and you can keep going in circles and circles and circles until you break something, unless you put a break somewhere to say, all right, at this point, let's break this loop, and then you can break and get out of this. All right, so the start is connected to the end. That's one characteristic of a loop. All right, and you cannot get out of this loop unless you put a break on it. So this is really going to be some of the interesting concepts that we look at when we talk about loops in programming. So just bear with me in mind the concept we've talked about here, the start connected to the end. You cannot get out of the loop unless there is a break. So as we dive into the topics, what we've seen here is going to relate to that. So that said, let's switch over to our working area and look at the very first topic within this module. And that concept would be the idea of the for loop. So let's look at what the for loop would be. Let me zoom in here for a second so my screen is more visible, move things around. So we're going to look at the for loop. And to do that, we're going to start by initializing some variables. So let's say x, y, z. All right. And then we're going to say x is 2. Let's say y is 5. Let's do 3. And then let's do 5. And then I could go and do 7, kind of like your primes, right? Let's just do a x y z. All right, so we're initializing these variables. Now if I wanted to go ahead and print these values to see them on the screen, the way we've seen to do this is to go ahead and print a. All right, and then we can print a and we see some result, and we see a result 2, and then we can go ahead and print b, and we're gonna see the result. But this is trivia. This doesn't really address that concept of loops for us. So if I go ahead and print b, actually we don't have b, we have x, and what will happen here is I'm gonna see a result. So 2 and 3. All right, that's interesting. But where does loops come into play? So where does loop come into play, guys? And this is what we're gonna address. This is gonna introduce a new concept for us in order to talk about loops, which would be the idea of arrays. I mentioned this a little bit in one of the previous modules. I think it was module 1, talking about the different data structures within Python. Array is one of them, and that's a very interesting topic. So when we talk about loops, more often than not, we're going to be seeing arrays, or a collection of items that we can kind of go over, right, and keep going from the beginning to the end, and then kind of coming back because the end is connected to the beginning. So let's change this. All right, and since this is the list of primes 2, 3, 5, 7 continues, let's actually just call this primes. All right, so this is a list of primes, and now we're going to define this into a new data structure here, and this would be our array. All right, our array of primes. Now I want to go ahead and print every single item in this list. All right, and now this is where the idea of loops comes into play. So we're gonna use a for loop for this. So this topic here is talking about for loop. we're going to introduce the idea of a for loop to see how we can go ahead and print every item that's available within this array. So how do we go ahead and do that? So the syntax for for loop is, let me zoom in here for a second, move this down. All right, that's going to be for prime, and I'm going to write it really quick, and then we're going to talk through it. So for prime in primes, all right, I want to print prime. All right, so very simple. So for prime in primes, I just want to go ahead and print prime. So let's run this and see. So what do we see here? All right, it prints out 2 3 5 7. So this is the whole idea of a loop. All right, guys, remember we went through this exercise, or we did this simple exercise just for illustration to say if you have something like this, which is a circle, it's just an armband, and say 2 was a start and 7 was the end, you can kind of go around, and if the start is connected to the end, and then you have a loop, and the loop breaks when we reach that end. So just again have that in mind as we kind of go through these exercises for what loops is. At the core, this is the simplest loop we can possibly write in Python. So if I give you a collection of items and say iterate is gonna be one of the terms that we should be familiar with. I say iterate through the loops, so we're simply writing for prime. So prime now represent each individual item in that loop. So it's gonna take the first prime, and that first prime will be 2, and it's gonna print it, and then it's gonna go take the next prime, and that next prime will be 3. It's gonna print that, and it's gonna go to 5, and it's gonna print that, and then it's gonna go to 7. It's gonna print that. So it's gonna keep printing until it's kind of gone through every item in the array. All right, so that's really the power of loops within Python. Now, this is a basic loop, and we can take this even further to print some more interesting loops. So let's say we had a list of languages. All right, we can define a list of languages, and those languages could be, instead of just having numbers, we can make them to be strings. So we can say English, French. Guess what? Python is a language, isn't it? So let's just add Python in there. And then last one is Gemba. All right, so those are the languages that we have. 4 languages. Now, how can we iterate to print all these languages on the screen? Again, the concept of loops comes into play. So we can just simply have a loop, just go for each language within languages. We should go ahead and print that language. So building on what we did before, this should be a very straightforward loop to write. So we can just simply say for language. If you notice, when I use language, I'm using it as a in singular, right? Because at this point, language should be an individual language within languages. So languages is my collection, right? Primes is my collection, and then for each prime in primes, and that's why you can see the difference in the way those are written. All right, so for each language in languages, all right, it could be for each student in class, it could be for each citizen in country, it could be for each customer in company, it could be for each employee in, so just simply pick your singular and your plural, and you can iterate through that. So let's just keep the languages in language. All right, so what we're gonna do is gonna go ahead and print language. That's as simple as it gets with loops. So if I run this, it's gonna print the numbers first, and then it also goes below that and it prints every single language. By the way, Ngemba is one of the languages that I'm very familiar with. So it's a language within from the West African country of Cameroon. Now, that said, this is some basic loops. What would be fascinating, guys, is if you can take this concept, think about certain collections of your own, define that into an array, and see if you can print that iterate over that and print the items on the screen. Now, we're simply printing on the screen, but we can certainly do something more exotic. So this would take us into another way in which we can iterate over items in a collection, still using loops. And this would really be the idea of a range. So we can say, and let me go ahead and comment all the stuff that we have here. So we can make some space, and then we're going to introduce that concept of printing items within a range. So if we don't have an array, but we simply want to print something within a range, how can we go ahead and do that? And the way this can come into play is if somebody say, write a program that can print all numbers between 1 and 10, all right? How can we go ahead and write a program that can just run through and print every single number between 1 and 10 as a simple example? So what we're gonna do here, again, we're familiar with our loops. We're gonna say for. All right, now we're saying number in. Now instead of having a collection of numbers, we don't want to specifically define a collection of numbers, because what if that number was print every number? What if the requirement was print every number between 1 and say 1,000,000? All right, if you go ahead and you try to put that in the list, it could be very difficult to handle. So what we do here for this is we're gonna use a range. All right, and we can specify that range given that as any number. So let's say that range is 10. All right, and now we're gonna say print number. All right, so there are many ways in which we can use loops to print on the screen. Well, it's printing 0 to 9 because in computer science or in Python, it starts counting from 10. So if I really wanted to include 10 in there, I would have it go all the way to 11. All right. So now this range is simply specifying that, you know, this is the upper bound of where I want to print, and then it starts printing every number up to that. So we can either define a collection in a list or an array before, or we can simply use something like a range to define where we want to stop our loop. So again, a very, very powerful concept within Python. Now, what if I didn't want to spend the number? What if I didn't want to write the number here? I wanted to do something more interesting. So let's take this example back. Let's say I had my languages. Let me just comment out the right piece of code, and then I'm gonna be left with my languages. And instead of printing out languages, I am going to comment that out as well. Move it to the comment section, and now we're left with this. All right, so we're left in this, and I'm gonna replace that with language, and I'm gonna take that for language in. Now, instead of specifying the number here, what we can do is to say we're going to use a string function to simply take and get the list of the number of items in this. So how many items are in here? Of course, we can count that to 4, and we can specify 4 in here. But if I don't know what this number of items are in here, I can get that number by simply taking length of languages. All right. And this function, length of languages, is going to count every item, the number of items in this collection, and it's going to return me that value. And that value says 4. And then now I'm saying that my range is, this is just like saying range is 4. All right. But instead of specifying 4, I'm simply figuring that out by using the length function to count the number of items within this particular array, within this particular list. So now, if I run this and I go ahead and I print, I can go ahead and print language. But if I do that, I'm going to be missing something, because what will happen is it's simply just going to print the number. It's simply just going to print a number for me. But I don't want to print that number. All right. I don't want to print the number. What I actually want is to print the language at a particular position. So print the language at position 0. Print the language at position 1, print the language at position 2, print the language at position 3. That's what I want to achieve. And the way we do that is to simply go back into our languages. And the way we can identify the position of an item is to say language. All right. And this way, let's actually make this X so that it doesn't confuse. So it doesn't confuse us. All right. So I'm simply saying for X in range, and the range has been derived by counting that item is gonna print languages of position X. So if I go ahead and run that, now it prints this. But guys, here's where it gets beautiful, all right? And this is why instead of hand coding your number of values in here, I can just simply go ahead and add say Lingala, for example. I hope I spelled that correctly in my list. But this is gonna print Lingala because it's gonna take the count of that, the length of this, which will be, instead of 4, it's gonna be 5 now, and then it's gonna say for X in the range of 5, print the language at each of those positions. And this is what a for loop can do for us. A very, very powerful concept. And as we kind of go and advance into this, the modules that we're going through, guys, we're gonna be building a lot on for loops. A lot of things in Python, in programming in general, we cannot afford to hand code them. Sometimes we look at loops and maybe don't get the power of it. But guys, this is one of the most powerful, most interesting concepts within programming. It's very essential that we really grasp what is going on. So I can go into some more examples and give loops. There is a way to also do loops if we want to continue on the loops for ranges. So let me take away the language, keep that to the comment section. All right. So what we can do here too is also do say for X in we saw for X in say range 50, print X is gonna just print from 1 to, let's do 51. So it's gonna print from 0 to 50, which we can see on the screen here. All right, but what if I don't want to print from 0 to 50? I wanted to print from say 45 to 50 or 41 to 50. You can also specify that within your range in a loop. All right, so now you notice it starts printing just from 41 all the way to 50. So very, very powerful within loops. All right, guys, this is interesting, and we can also do some more. There are more customizations that we can do. This one prints, so it prints from 41 to 51, all right, or to 50, you will say, and it does so in increments of 2. If I did that in increments of 5, what do we expect? It should print us just maybe 1 value, all right. So there are more, actually 2 values. If I did that in increments of 7, then I should get 1 value printed out, because there's, yeah, never mind, I should do my math correctly. Yep, for the one, if, oh, okay, let's keep going. I want to do something that is more than, actually, let's do 12. Yep, this should definitely print us 1 value. There you go. All right, guys. So there's more things that we can do in loops, more controls, and this really gives us a lot of flexibility when it comes to writing code. So I'm going to move this into the comment section here, but I encourage you guys to really play with loops. It's very, very powerful. And the next concept we're gonna see after loops is look at, or after for loops, is to look at the loop type called the while loop. And I'm gonna make sure that I get it correctly here, the while loop. So the concept of the while loop within Python. How can we take advantage of that? How is it different from a for loop? And what does the syntax look like? That's what we're gonna look at in the while loop. So for the for loop, we saw that very, very straightforward. For X in a particular range, go ahead and print the value. How is that different from a while loop? I would argue it's very similar. It's very similar. But instead of a for, we're using a while statement. So let's just go and say, define a particular variable here, and let's call that variable count. All right, so we're going to be counting. So I want to say keep counting until you've reached a certain number. So I could say keep counting until you've reached 5, until you've reached 10. All right, and this is what this is going to help us do. So let's say X equals 0 while, actually count equals 0 while count, all right, is less than 15, for example. So we're going to go ahead and print let's go ahead and print count. So we're gonna go ahead and print that value, but we can't just stop there, right? Because then how does count change? So we can now say count equals to count. All right, so we go ahead and increment the value of count, or this will always add a more than we want, so we can say count equals count plus 1. All right, so if we run this, let's see the result, and then we'll kind of talk through it. So it started and said 0, 1, 2, 3, 4, 5, all the way to 14. And then when it reaches the point where count is greater than 15, it doesn't print, because this is what the while condition is telling us. So count equals 0. So let's kind of break down the syntax and make sure that we understand what's going on. While count is less than 15. So if that value, we start from 0, is 0 less than 15? Yes, 0 is less than 15. So go ahead and print 0. Now we increment. So 0 plus 1 is what? 1. Now we go back to our while statement and say, all right, 1. Is 1 less than 15? Yes. Go ahead and print 1. Now we increment 2. Now we go back again, right? So it's going to keep doing whatever we have in the while statement until that condition is broken. So by the time we reach 14 and we print 14, now we're going to go ahead and look at 15 and say count equals 15. Is 15 less than that? Nope. Then so the count, the while condition is not met, and then it stops printing, and that's why we can print only to 14. So while conditions, for loops, very, very powerful within programming, right? Using this in combination, guys, you can do a lot of things. You can do a lot of things within programming. But let's go more and look at some other scenarios of while statements, and we'll do this by actually writing a simple while condition that can check for, say, all the even and odd numbers within a particular range. If I say, okay, go ahead, write a computer program that you can check for all the even numbers within the range and tell me if that number is even, it should tell me. If the number is odd, it should tell me. All right, so that's what we're gonna do to really put into play this idea of the while loop. So how can we do that? We can start with count. Simple again, we don't need to change that, or we can maybe change this to say number. All right, since we're working with the numbers, so number equals 0. All right, now if our range is say 100, actually let's use 20 so that we don't go too much. All right, and then now we're saying if that number, while that number is still less than 20, what are we trying to do? We're trying to check. Let me cancel everything. We're trying to check if the number is an even number, tell us. If the number is an odd number, tell us, right? So when we reach 2 is an even number, it's gonna print 2 is even. When we get to 3, no, 3 is odd, tells us 3 is odd, and then 5 odd, 6 evens, and that's how this program is going to work. So if we proceed to this, since we know a number, now the question is we need to check. But guys, we remember we did understand how to do if statements. So we want to check to say if number, all right, meets a certain condition, all right, and let's just put a placeholder here so we can see how the code is gonna come into play. All right, the syntax is not correct, but I'll fill it in just so we see how we build it up. So if number meets a certain condition, all right, now what do we want to do? A condition that tells us that it's even, we want to print to say, all right, string, let's take string, convert that to a string. Let's add a plus there, bear with me, is an even number. All right, so that ends that. Now, if it's not that case, what do we want to do? And I'm just keeping this simple. We want to do an elif. All right, let's just play, because there's just two numbers in math, right? Even and odd. Unless somebody has invented something new, I feel like our else statement. Let me not do elif. Our else statement should be pretty safe. All right, and at this point we want to print number converted to string. is an odd number. All right, so this should give us a very simple program that can go ahead and check if now we need to figure out that condition, but let's assume that there's some condition that we can use here. If that condition is true, we want to print it's an even number. If the condition is false, we want to print it's an odd number. But we cannot end here. From the previous exercise, we saw that we have to increment our number. All right, so now we gotta say number equals number plus equals 1, right? So we increment that by 1, and that's how we're gonna keep going back and coming back and looping until that condition isn't met. Now, how can we figure out if the number is even or odd? If you remember in the previous lectures where we worked with numbers, there was a mathematical function or a mathematical operator that was let me explain it down here. That was, if I say 5, all right, mod so if I say 5 mod 2, for example, what is this? This will be equals to 1, right? All right, now if I say 6 mod 2, this is equals to what? 0. All right, if I say, you see where I'm going with this? If I say 7 mod 2, this is equals to what? 1. If I say 8 mod 2, basically the remainder. So 8 divided by 2 is what? 4. Remainder, nothing. There's nothing that remains, right? So this will be 0. And if you keep going, what you'll notice is you're seeing zeros and 1. Zeros, 1, zeros, 1. All right. So this one that is a 1, what is that? This is what? Odd number. This is an even number. All right. And it kind of keeps going back and forth. So if we do the number mod 2, if the number is 1, then we're dealing with an odd number. If it's 0, then we're dealing with an even number. All right, and this is what we can now use as a check within our function. So let me go ahead and delete that. So now we can come in here and fill in the details and say if number mod 2 equals 0, all right, there's no remainder, then we know that's an even number. Otherwise, else, it means that there is a remainder, and that has to be an odd number. All right, and so that has to be an odd number. So we can go ahead and print that as an odd number. And then once we've printed that out, bear with me, I have an additional bracket here. So now once we printed that out, and if we run this, let's make this look pretty so we can run it again one more time, and then you have it. All right, it can tell us 0 is an even number. 1, we really shouldn't start from 0, but we can start from 0. 1 is odd number, 2 is even, 3 is odd, 4 is even, 5 is odd, 6 is even, 7 is odd, and you can go ahead and see that. All right, guys, so this is the power of while conditions coming together with if statement, if else conditions, which we saw in our previous modules of conditionals, and being able to, given any number, tell us if that number is even or odd. All right, guys, so very, very powerful. You can take this and take that all the way to 20,000, and the code now in Python, it ran in a very short time, and it can tell you. Imagine having to do this by hand with a calculator, guys. That would be mission impossible. But with Python and the power of if statements, guys, you can figure this out to 20,000 or 2 million with a very simple script. All right, basic but very, very powerful concept. Now, this takes us into a next concept, which we're gonna cover a next module within this module. So we're gonna cover a new concept here, and let me clear up everything we have on the screen. And that's the idea of being able to break and continue within loops. All right, so what we've seen here is we can do for loops, we can do while loops, we can take while loops and mix them with if conditions. But if a while loop is going, how can I break out of that while loop so that it stops? This is what this particular concept would tell us. And the example that we're going to use for this would be, again, going through the scenario of being able to print. All right, let me well, let's just implement a new one here. Let's just say count. All right, we want to start again with count equals 0. All right, and we're going to do a very simple while loop here, right? So while count is, say, greater than 15 as an example, what we're gonna do, and just bear with me here to make sure that we're following the same content. All right, or let's actually do it this way. Let's say while true. All right, because it's always going to be true unless we tell it to be false. While true, we want to go ahead and do something. All right, let's go ahead and print count, and then we're going to increment count. Bear with me. So we're going to go ahead and increment count plus 1. Now, if I just simply leave it at this and I run this code, what's going to happen? This would be a problem, because I've just simply said while true, whatever true is just always going to be true, right? Because remember, while conditions are just simply checking if some condition here is correct, right? But if I've just forced it to say that condition is always correct, and this is while true, print count and increment count, then we're going to put ourselves into what is called an infinite loop, because there's nothing to ever break this. I'm going to run it, but I'll stop the code because it's never ever going to stop. So if I run this, all right, you see it can print from now to eternity, and it's never ever going to stop because there's no condition that I've put in here to stop this from going to an infinite loop. So that's what we need to fix. Now I'm going to pause this because I can go forever and ever, and then we want to figure out how to be able to break infinite loops like that. So how do we do it? We can now throw in a condition in there to say if count is ever greater than 35, greater than or equals to 35, all right, now we want to do something. And what is that thing we want to do? We want to break. All right, as simple as that. We simply just want to break this loop and never continue again. If we ever reach the point where count is greater than or equals to 35, just go ahead and break that statement. Now this is as simple as writing from counting from 1 to 30, counting from 0 to 35 or 1 to 35, 0 to 34 or 1 to 35. And so there you go. We've introduced the idea of being able to break out of a loop. All right, and if we can break by just using the statement break, we can equally continue by using a statement continue. And that's what we're gonna do in the next scenario here. And for this one, we're gonna do a for loop. All right, so for x in range, and let's just write a quick for loop here, and let's make that range 10. All right, so what we can do here for an x, we can say if x is let's do a simple check. If x is an even number, meaning that that will be equal to 0. All right, if x is an even number, then we want to go ahead and print x. All right, we want to go ahead and print x. Actually, we should go ahead and just continue, and I'll explain this a little bit. Otherwise, we want to go ahead and print. X. All right. So for x in a range, and let me comment this previous code out. So for x in a range, so counting from, starting from say 0, right, and the range is 10. If that's an even number, we want to continue. If it's not an even number, we want to print x. So what are we going to see on the screen? We're going to print only odd numbers, because if it's an even number, right, if this mod is 0, it's not going to print anything. It's just going to continue the loop. We could have decided to break the loop and just stop it right there once we see the first even number. All right, but in this case, we're gonna print all odd numbers. So let's go ahead and run this. Now it just prints us all the odd numbers, right? If I change my range to say 1,000, this will print all the odd numbers from 1 to 1,000. All right, because it's gonna say if it checks the condition, is this an even number? Basically, when you're doing mod 2, it says nope. It says yes, it's an even number, and then you just say continue. It doesn't print anything, it just continues. And from here, it continues back to the loop. It doesn't continue to print this. It continues back to the loop, all right, and it continues back to the loop. And otherwise, if it checks and this is not uneven, so there's a remainder, which means it's an odd number, then it's gonna print that X. So let's run it to 1,000, and you can see all the odd numbers from 1 to 1,000 are printed. So that's the idea of being able to use break conditions to break out of loops, right? Because remember when we showed this example, if you have a loop and we're just kind of going in a loop, you can never come out of that loop unless you say, if I reach a point where I feel like a metal that I have here, right, on my band, then break out of it. Then that condition breaks out, and then you don't have a loop anymore. But if I don't put that break condition, it will never break out of it, right? If I just say, if you reach this, continue, it's just gonna keep continuing and going like that. All right, so that's how we can use continue and break within functions, within loops, to be able to achieve a lot in Python. All right, guys, this takes us as a segue into the next concept we're gonna cover, and let me move this aside, and that will be our concept 513, right? So we're still on 512, and if you look at 513 is gonna talk about else clause for loops. All right, so if you can do if conditions within loops, we can certainly do else conditions within loops. And I'm gonna just write a very quick while loop here, and then see how else conditions can be used. So while, let's do while count. Well, we need to set count first before we're using count. So we always want to initialize count equals 0 while count less than 15. All right, we want to go ahead and do something now with count. And what we're gonna do here with count is we're just simply gonna print count on the screen. So let's print count on the screen. Now we know if we're printing count on the screen, we're gonna go ahead and increment count again. All right, or 1. So increment count by 1. But so let's just see what we've written here. Very simple. We've done this many times by now. While count is less than 15, print count increment count by 1. So it's just simply gonna print from 1 to 15. All right, but what if that condition is not met? All right, so we can throw in an else condition, because if you think about it, this is simply an if statement. We're simply saying count less than 15. Is that true? Do something. And if you have an if statement, guys, you can always accompany that with an else condition. And similarly, we can throw in an else condition here and say, well, what if this condition that we're seeing up here is not met? What should we do? What if count is not less than 15? All right, what do we do? What do we print on the screen? That's what we're gonna figure out now. All right, and we can throw in now a print condition here and say print something, and say value of count is has reached, and then we can of course always concatenate something in there and say has reached a string of count. All right, let's just convert that to a string, and if we run this, it's gonna count from 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14, because we're counting to 14, and then it's gonna can't count anymore, and then it breaks and then prints this. All right, so let's go ahead and see that. Now you see, once it reaches that, it goes into that break, which is the else, and then it prints the value of count has reached 15. All right, so very similar to the way we use if statements, guys. We can also, and if and else conditions, we can use else within while conditions. So we had if something, and then do something else, do something. Now we're saying while something is true, do something else. If that's not true anymore, do something else. So while, and it's a very powerful statement, and combination with else, guys, there's a lot that you can do to break out of the loops that you might find yourself in. And if we can do if we can do else in while conditions, we can equally do that in for loops. So I'm gonna do a quick for loop here, change that to a 5 so we don't print a lot on the screen. All right, and then I'm gonna say let's just modify this on the fly, say for x in range. Let's make that range what? Guys, give me a number in the comment section. What should we make this range? All right, 5. Is 5 a good number? All right, I think 5 is a good number. So let's say print let's make this count, just so I'm not changing a lot. All right, print count. Otherwise so we're gonna go ahead and print count. Otherwise we want to, else we want to go ahead and print this. I'm just gonna leave the syntax exactly the same, just so that nothing changes. So 0 1 2 3 4, and then we've reached that. Now this next one, where is the for loop, again behaving the same. So whether we're looking at the while statement here or we're looking at the for condition, we're still achieving the same result on the screen. So this is the for loop printing the same thing. This is the while statement printing the same thing. All right, guys, very, very, very powerful. For loops, while something is true until it reaches the criteria, do something. For statement says for every instance of a particular variable, you can do some checks and break out of it or continue doing what you're doing if it makes sense. All right, guys. This is gonna take us as a segue into the next topic, which will be nested loops. So if you can do single loops, you can equally nest them. And let me copy the concept here so we have the exact number, which would be 514. So module 5, lecture 1, concept number 4, which is the idea of nested loops. And we can go ahead and clean up everything we have on the screen except our count. All right, so we can initialize count equals 0, and now what we're gonna do is start doing our loops. And we can say while I'm gonna do a simple loop here. We're gonna say while count is less than, let's make it 10 as an example. We want to go in there and do something. All right, now we're gonna say we're gonna throw in another loop, right? Because the whole idea here is talking about nested loop. We're gonna say we're gonna throw in another thing here and say while count mod 2 equals 0. All right, so we've nested that loop. We want to print the number is the number. Let's actually put the number in there, a string, because that's still a number there. I want to do a string of count, and then we want to add is even. All right, so we saw this concept before, and the idea of being able to figure out an even number is simply take the number mod 2. If there's no remainder, which means that that's 0, then it's even, otherwise it's odd. All right, so while we're starting from here, while count is less than 10, all right, and that starts from 0. Is 0 less than 10? Yes. Now we're coming in here. All right, now while count is mod 2 divided by 2 is equals to 0. All right, so at this point we're starting from 0. We want to print the number is even, and we're gonna do that, right? This loop is gonna finish before it comes back to the outer loop. So the inner loop is gonna finish, then come back to the outer loop. Let's see the result, and then we can explain through that. All right, so it runs, but there is a problem, because now I'm putting myself into the position where it's printing this, but it's never ever gonna stop. So we're gonna somehow have to stop this, which I'm gonna stop on the screen, and then put in a condition in here to break out of this statement. All right, and we can either put that condition by putting a check to say if let's say well, we're gonna have to increment count here. That's part of the reason why we're missing this. All right, we're gonna increment count and say count equals 1. All right, and then we can also go ahead and increment count on this outer loop. All right, so we can increment count on the inner loop, and we can go ahead and increment count on the outer loop, but this would be always breaking out very quickly. And the reason why I'm going through this exercise, so we can see how loops can be very tricky, and it can give a lot of problems in your code if you don't really pinpoint where the loops can go infinite or the loops doesn't break. You can have a lot of issues, because this clearly here will give an issue. It's going to print this and then quickly break out, because once it changes the number, it's not going to be 0, and I break out of that, and then I can increment my count. So it's very very interesting. So you can see I print 0, 2, 4, 6, 8, and nothing else, right? If I took this out, if I took out this single line, now I get myself back very quickly into an infinite loop. All right, so very, very, very important to make sure that we know and understand where we're breaking loops and what condition is triggering what to happen. So like here, the reason why this is very essential is if I don't increment by 1, then while count to always just remain whatever the first number was, which is 0, and it's always just gonna print out 0. There's nothing to break that out. But once I increment to 1, it checks for that, increments, and then becomes 1, and it checks it's 1 mod 2 equals to 0. Nope. Then it breaks out of that. All right. So very, very powerful. And if we do it in while conditions, we can also do this in if statements. All right. Interestingly, I have the if condition, the one for the if statement already here. So I'm gonna just place that on the screen. We can just go ahead and read this and discuss through this particular code. So guys, very similar. In this case, we're initializing a number. We're gonna say number equals 0. All right, and let's put that on the same level. This would be a problem. Python usually likes the syntax, so I'm gonna have to take everything out of the screen so we have a clean indentation. Delete everything. Bear with me. Once that's deleted, I think I missed that. All right, there you go. I still have a lot of stuff. The indentation has to be exactly correct, or your code is not going to run. All right, so this is an interesting one to tell us what part of the loop is printing. All right, so here I have okay, so here we have a for loop. So for in range 1 to 3. All right, we're printing. All right, the outer loop iteration. That's fine, and then we'll go in for another number in range 1 to 5, and I'm printing an inner loop. So it starts 0, and then it goes into this loop and it prints 1 to 5, and then it goes 1 and it goes into the inner loop, it prints 1 to 5, it goes 2, 1 to 5. So 1 to 5 is printed 3 times. All right, that's the idea of being able to use an inner loop and then an outer loop. All right, so if you can see, it goes from that the first outer loop, and it starts with 1 and it prints 1 to 5, well 0 to 4, and then it goes in there, the next one it prints that, and it goes here, it prints that. So basically printed 3 times. All right, so we can nest loops as deep as you want, right? You can have a for loop and then a nested loop and a nested loop and a nested loop, but of course the more nested you make your loops, the more difficult it is to read code, and then the more something is easily gets broken or easily gets missed. So I highly encourage, if you're going to be making complex loops, to keep them simple, to keep them readable, and not do something that would be too crazy. Now I have a challenge for us. I can go through more of the exercises that we have, but guys, I will encourage you to check them out within the code that I have in Git, in my Git. So there's examples on nested loops, which you've seen. The next example would be around being able to break loops within Python. And again, we're just simply using the break statement, right? Or you can simply leverage the continue statement, which you saw earlier. So trivia, by this point, we've seen a lot of that in this particular lecture. So just go ahead, grab the code under loops. That's module 5, the very first code in Python. That's going to be in my GitHub, and then play with that. Now, what I want us to do as an exercise is to write a loop that can print a triangle. So it's gonna print something like, just bear with me if I can get the right key on my screen. All right, so it's gonna print something like, let's make this actually simple. Just make this simple. I was gonna make it interesting, but this is the exercise, guys. Leave your comment below in the comment section, or share your code if you so like, so we can see what you did. All right, so some. All right, so can you write a loop that can kind of go through and print out something that looks like this? All right, how would you do that? I'm kind of curious to see how you will solve that, right? I can tell you for a hint, you will need an inner loop and then you need an outer loop. An inner loop to bring you down, the outer loop to increment the number of times that you print star on the screen. Very doable within the loop, guys. If you work on this exercise, go into the comment section below, leave your code. I'll be very interested to see. If you have any challenges with it, let me know. The code isn't available in my GitHub, but I can certainly put it together and share with you if you have any questions. All right, guys, so there you go. Thanks for joining for this particular lecture. Really appreciate you. Loops are a very, very powerful concept within Python. For loops, while loops. Just to recap what we've seen: for loops, while loops, nested loops, breaking loops, else conditions. Guys, these are all powerful, and I really want to encourage you to get familiar with them. And the way you can get familiar is just to practice. Practice. Have scenarios. Write a loop that can print all the, numbers divisible by 5 within 1 to 10,000, for example. Guys, you can certainly do that by leveraging loops. All right, thanks for watching. This is Fru. I'll see you in our next lecture, which will be talking about functions. So stay tuned for that. Functions is what we're going to be talking about.